Hello, everybody. We continue with chapter 9. I'm experiencing this live YouTube video. Hopefully, I'm not going to have any restriction on the time and the capacity. In last video, I did cover first part of chapter 9. If you guys use the old PowerPoint, 9AA, now we go to 9BB. The last problem that I solved, I think it was problem number 33. And now we go to part B, 9BB of old PowerPoint. On slide number 3, they're using, in second part of chapter 9, we're going to do the hypothesis testing very similar with what we did when we were using the population mean. But this time we are going to use the proportion. We are going to substitute the mu with the lowercase p, which is the population proportion. If you guys remember, just to refresh you guys' memories, what the proportion is, it is a fraction for the population. It's a fraction of population with characteristic of interest. Example, let's say that I have 100 students and I ask these 100 students how many of them are going to apply for graduate school. Let's say that 70 say that they won't do that. So 70 divided by 100, that is 0.7. If I take a sample of 20 and I ask the same question from these 20 students that if how many of them are going to apply for graduate school, then let's say 15 out of 20, they say they won't do that. So 15 divided by 20, that is going to be my sample proportion. The key thing in here in proportion is that we have to use the same criteria for both population and sample. What do I mean by this? If I did ask the question about applying for graduate school from my population, I have to ask the same question from my sample. Now, using the population, listing those 3 cases of hypothesis testing, this is the lowercase, one tail, lower tail, and then H0 states that lowercase b less than or equal to p sub 0, and then HA states that the p is greater than p sub 0, and then two-tail hypothesis testing. So this is one tail, upper tail, and then two-tail hypothesis testing H0 and HA, where p is equal to p sub 0, p is not equal to p sub 0. So everything stays the same in terms of the calculation of z statistic, and the only difference is that sigma sub p bar is going to be different, and your z formula is going to be a little bit different. Your z formula is going to be p bar minus p sub 0 divided by sigma sub p bar. And we only are dealing with sigma known case. We don't have no sigma known case in this case in here. And here is our formula. Z is equal to p bar minus p sub 0. So sigma sub p bar, which is equal to p sub 0, 1 minus p sub 0 divided by n. So this is the only difference that you see. And of course, instead of the x bar and the mu sub 0, we are using sample proportion. This is hypothesized population proportion. This is a standard error of P bar or a standard deviation of P bar, whichever you call that. And the rejection rule stays the same. So reject H0 if p-value is less than or equal to alpha z calc greater than or equal to z of the alpha, negative z calc less than or equal to negative z of the alpha, and the same thing for two-tail z sub alpha over 2. And we can say the same thing, negative z calc less than or equal to negative z sub alpha over 2, and then z calc for positive greater than or equal to z sub alpha over 2. So these are the, sorry guys, let's see if I can move this up a little bit that you guys can see those rules. Okay, if I raise this, I think this much, then I'll be able to have more area of the board to be shown. Let's see. Well, let's just move on for now. There's an example on slide number 6 of the second part of the PowerPoint slides of chapter 9. For Christmas and New Year's week, the National Safety Council estimates that 500 people would be killed and 25,000 injured on the nation's roads. The NSC claimed that 50% of the accidents would be caused by drunk driving. A sample of 120, this is your N, accident showed that 67 were caused by drunk driving. Use these data to test the NSC's claim with alpha equal to 0.05. The first step is to develop the hypotheses. So developing the hypotheses. H0, they said that 50%. The problem says 50% of the people get injured or killed. They say 50%. So P is equal to 0.5. HA states that P is not equal to 0.5. Step number 1. Step number 2, this is step number 1. Step number 2, specify level of significance. Alpha is equal to 0.05. Step number 3 is calculate the test statistic. Step number 3. Z is equal to P bar minus P sub 0 divided by sigma sub P bar, which is actually P sub 0, 1 minus P sub 0 divided by N. So Z is equal to, okay, I still can use this. So P bar is, they said what, 120, excuse me, to find P bar, I have to go back. We had 120, showed that 67 were caused by drunk driving. So we do for P bar, so P bar is equal to 67 divided by 120. This is our sample proportion. Okay, so 67 divided by 120. So in here we say 67 divided by 120, whatever that is, minus P sub 0, which is 0.5, divided by, this is not good. Let's see, guys. Okay. So 67 over 120 minus 0.5 divided by sigma of 0.5, 1 minus 0.5, and the sample is 120. Okay? And your Z comes out to be equal to 1.28. 1.28. Okay? So this is our Z. Now let's continue over here. We have to go to Z table. Let me see if I can get this off of here. If this is going to make it a little easier for us. If we have this right here. Still, this needs to come up like this. All right. Let's see if I can put something like this box. Sorry, guys. This is the first time that I'm doing all these things. All right, I think this is a lot better. Okay. Yep. This is a lot better. All right. Yep. So now we have Z equal to 1.28. This is equal, not equal. We have to go to the Z table and find out what the area for the Z table would be. The area is for 1.28 is going to be 0.8997. If I'm going to show it to you guys like this. So this is 1.28, let's say right here. This is 1.28. So this area is 0.8997. 0.8997. This is on slide number 9. So we do, since this is equal, not equal, two sides, 2 times 1 minus this, 0.8997. So our p-value will come out to be equal to 0.2006. 0.2006. Now, comparing this with the alpha, our p-value is greater than. So p-value is greater than alpha. P-value is 0.2006, greater than alpha, which is 0.05. Therefore, do not reject H0. So unfortunately, we have to accept that, yes, we're going to have 50%, or in this case more, because 67 is more than half of the 120. So we do not reject. If we want to go ahead and use the critical value approach, the z-value approach, look for z-value approach. So the z that we calculated, z-calc is equal to 1.28. Now let's see what z of the alpha is. In this case, z of the alpha over 2, right? So alpha is equal to 0.05. 0.05, half of it would be what? Half of it would be, half of right here, 0.025. If this is 0.025, this area is what? This is 0.975. So we go to the z table and we start locating 0.975 on the z table. for Z table 0.975 would be the one with the black mark. .975. So that, if you read the corresponding value of Z to that, so Z of the alpha over T is going to be 1.96. So the rejection rule says reject H0 if Z calc is greater than or equal to Z of the alpha. But in this case, our Z is 1.28. It is not equal, it's less than Z of the alpha over 2, actually, which is 1.96. Therefore, do not reject H0. All right? This is on slide number 10. Now we're going to go ahead and do problems. Problems number 35, 36, and 38, and this is going to end chapter 9. Let's see. Problems. No, I don't have to rush because of the time restrictions or limitations. Problems number 35, 36, and 38. 35, 36, and 38. Let's see. Problem number 35. They start, these are the page numbers where they start. For 11th edition, page 379. For 12th edition, page 414. For 13th edition, page 419. Okay? Problem number 35, you go ahead and read that, and we're going to go ahead and start solving for this problem. This is given. So Z, oops, sorry, H0, HA, P equal, P not equal, 0.2 and 0.2. This is given. For part A, sample of 400 provided a sample proportion P bar 0.175. So N is equal to 400, P bar is equal to 0.175. 0.175. Right, let me put this right here that I don't have to go back and forth. .175. Part A, compute the value of the test statistic. So Z is equal to P bar minus P sub 0 divided by sigma sub P bar, which is actually P sub 0 times 1 minus P sub 0 divided by N. So P sub 0 is 0.175 minus, I'm sorry, P bar, lowercase p bar, sorry, is 0.175. P sub 0 is equal to 0.2 divided by square root of 0.2 times 1 minus 0.2 divided by N, which is 400. So Z comes out to be negative 1.25, negative 1.25. That's for part A. For part B, what is the p-value? So we go to the Z table for negative 1.25. This is positive. For negative 1.25, the Z value is 0.1056. So we say 1 minus 2 times, sorry guys, 2 times 1 minus 0.1056. So this is the area for negative 1.25. That's one side because this is equal, not equal. This is one tail. We have to subtract it from 1 and multiply by 2 to get the actual p-value. So our p-value comes out to be 0.2112. 0.2112, that's our p-value. Part C, at alpha equal to 0.05. So this is the p-value. This is for part B. For part C, alpha equal to 0.05, 0.05. What is your conclusion? So our p-value is 0.2112. Our alpha is 0.05. Therefore, we do not reject because our p-value is greater than value of the alpha. So do not reject H0. So we do not reject H0. Now for part D, what is the rejection rule using the critical value, and what is your conclusion? So we go ahead and do part D up here. This is for part D. So Z that we calculated, that's for negative Z calc. It is negative 1.25. So if this is negative on the other side, that means we have to go ahead and find the Z of half of the alpha. Z of half of the alpha. So Z of half of the alpha. Half of the alpha is 0.025. So it's going to be, for positive side, it's going to be 1.96. Since this is negative that we calculated, we assume that we have to compare it against negative Z of the alpha over 2. So this is going to be negative 1.96. Our rule says if this is smaller than this, reject. But in this case, this is larger than this, then do not reject H0. H0. Problem number 35. Now, problem number 36. Consider the following. I'm going to write down those hypotheses here for you guys. This is problem number 36. Chapter 9, problem 36. H0, HA, P greater than equal 0.75, less than 0.75. Part A, in this case, in problem number 36, I'm going to do only 2 of them. All right. I'm going to do part A and part B. Part C and D, you guys go ahead and do it as a practice on your own, because these are the same. They're just using different value for lowercase p bar. They're giving us 4 different values. I'm going to do first 2, A and B, and then you guys do C and D. All right. A sample of 300. So N is equal to 300. Compute the p-value, state your conclusion for each of the following sample results. Use alpha equal to 0.05. And then for part A, they want us to use lowercase p bar equal to 0.68. Okay? So again, z is equal to p bar minus p sub 0, that's our p sub 0, divided by square root of, this is actually sigma sub p bar, which is p sub 0, 1 minus p sub 0, divided by n. So p bar 0.68 minus 0.75 divided by square root of 0.75, 1 minus 0.75 divided by 300. So z is equal to, let's see here, z is equal to negative 2.8. Negative 2.8. Sorry guys, I have to go get the power supply for my computer. I thought that I have enough power. I'll be right back. Don't go anywhere, guys. All right. Okay. Okay, we're in business. So problem number 36, part A, z came out to be negative 2.8. They want us to go ahead and compute the p-value and state your conclusion for each of the following samples. So we have to go ahead and find out what the p-value would be for negative 2.8. Go to z table. For negative 2.8, the z value is, the p-value is, so p value is equal to 0.0028, I think, 0.0026. This is our p-value. Compare against alpha is 0.05. We go ahead and reject because this is smaller than that. So we say reject 80 because our p-value is smaller than value of the alpha. Then I do part B as well. So this was for part A. For part B, this is 0.72. So this is going to be 0.72. This is going to stay the same. That's going to stay the same. So z is going to be equal to, for part B, z is going to be negative 1.2. So for negative 1.2, we go ahead and read the value off of the table, p-value is equal to 0.1151. So in this case, the p-value is not less than the alpha. Therefore, we do not reject. So do not reject H0. Okay? Now, problem number 38. I want you guys to go ahead and read the problem. Formulate the hypothesis test that could be used to determine whether the percentage of supermarket shoppers who believed that the supermarket ketchup was as good as the national brand ketchup differed from 64. 64, that is the proportion for those who believe that supermarket brand is just as good as the national name brand. So this is equal to 0.64. Is that equal to 0.64? This is part A. For part B, they want us to find what is the p-value if the sample of 100 for part, this is part A, for part B, it is equal to 100, showed 52 stating that, so and X is equal to 52. So in here we have to go ahead and find our sample proportion first. So sample proportion is equal to X divided by N. That will be 52 divided by 100. That's 0.52. Okay, that's our lowercase p bar. Now find the p-value. So we go ahead and do z is equal to p sub 0, which is 0.52, minus, I'm sorry, lowercase p bar, which is 0.52, minus p sub 0, which is 0.64, divided by square root of 0.64, 1 minus 0.64, divided by 100. So z comes out to be negative 2.5. So negative 2.5. We have to find a p-value. Just go to the table. For negative 2.5, the area is 0.0062. So p-value is equal to 2 times, because this is equal, not equal, times 1 minus, I'm sorry, this is negative, so we don't do 1 minus because this is just for both sides. 2 times 0.0062, that will give us 0.0124. So that is our p-value, 0.0124. If I want to show this to you right here, I can show it to you right here. So this is negative 2.5, negative 2.5. This area here is 0.0062. 0.0016 here, 0.0062 on the other side. We multiply by 2, we'll get 0.0124. That's for part B. Part C, this is problem number 38. So part C, alpha equal to 0.05, what is your conclusion? So part C, alpha equal to 0.05. The conclusion, our p-value is 0.0124. Our alpha is 0.05. So therefore, our p-value is less than alpha. Do not reject 80. 0.0124. If this is less than, let's see, p-value. 124. Probably on problem number 2, 0.05, alpha equal to 0.05. Let me see, I think I have made it. Hold on, guys. Did I say do not reject? This is why that I was reject 80, so I know that. Sorry about that. This is less than this, then reject 80. So it could happen to anyone, right? With all these reject, do not reject. Sorry, guys. That's part C. So go ahead and reject 80. And then part D, should the national brand ketchup manufacturer be pleased with this conclusion? This is part C. For part D, we say yes, because they have to reject the assumption that the supermarket brand is as good as national brand. So that is going to get rejected. That means the national brand ketchup manufacturer, they should be pleased with this result. So this ends chapter 9. This is about 37, 38 minutes. And the only chapter left is basically like half of chapter 14 and maybe just a little teeny tiny bit of chapter 12 that I will cover for you guys, of course, later. Maybe I will let you guys know that for chapter 14, when I'm going to go live, I will let you guys know at what time. For those of you who can join me, you would do that. I'll see you guys later. Bye-bye.